Thank you very much. My name is Andreas Faath. I come from the VDMA. Over the next 30 minutes or so, I'm going to tell you about our view on interoperability in connection with UPC-UA. I think it is clear to most of you, but I always like to inform you about the fact that we are a non-profit organization at the VDMA. We've got 3,500 members, and we want to represent the interest of machinery and equipment engineers, not only in Germany, but the world over. Everything I'm telling you does not only relate to the German machinery and equipment engineering market, but at least to the European market, and probably also applies to the global market. But we come from a different angle compared to the OPC Foundation, because we don't want to push a technology, but we want to really identify the needs and requirements in the industrial sector. And one of the most important needs in industry is digital transformation. We all know about that. In the field of digital transformation, we have defined the most important requirement, and that is a set of data. Data is not simply going to be made available, but it is to be harmonized, standardized, be made easily available, at best in such a way that it can be used by various different producers and manufacturers at the same time. We are already doing very well in the field of availability of data. We have the data and we can store it, but especially in the field of scalability, there is a lot of room for improvement. Information from different manufacturers need to be brought together in order to create something new out of that, or increasing the efficiency and making the data transparent. These are the challenges that we're currently facing, that we still have to deal with, because also comparability of data is important. If we don't have a particular standard that everything is based on, it's not all that easy, especially when you look along entire value chains. You have data available, but it cannot necessarily be used because the data apply to different levels of technology, different semantics and different meanings. And so this is why it's very difficult to process the data. Now, where are we headed? What is our goal? There are three important points that are particularly important to the machine and equipment engineers. This is where we have to become more efficient, effective, and cost efficient. And that relates to the development of interfaces. New developments occur again and again, although interfaces have already been developed. This is time-consuming, it's not economical, but very cost-intensive. And it really causes us headache because we're subjected to ever greater pressure in the international market. Secondly, we want to ensure the rapid integration of products and components in machinery and equipment engineering in the green field, but also much more in the brown field. So we have to become more faster, fewer integration days, low stop of production. We've got to increase efficiency. And the last point isn't a no-brainer to a certain extent, but it's always important nevertheless, because it's not only the person selling the machine, but we also produce machines and equipment. So we're wearing two hats. So it's not only about making the machines interoperable with the data available, but the manufacturer, the mechanical engineer in his production also uses data coming from his manufacturing process, being equipped with different machines. And that is why it is important to make the data interoperable, semantic, standardized. Well, we want to develop a global production language, standardized information from the shop floor. The companion specification of OPC-UA is what Mr. Hoppe just called it. To us, OPC-UA doesn't really matter. We use OPC-UA because it simply fulfills the requirements that we have as mechanical engineers. It contains security, Stefan Hoppe mentioned of it. It contains various different protocols. The system is international, had been accepted, implemented, adapted, but we didn't start off by saying, well, we want to develop OPC-UA companion specifications, but we want to standardize semantics. OPC-UA is the tool that's available to us. If OPC-UA 2.0 will be entering the market in 20 years from now, then the semantics will be the same. They remain most important to the mechanical engineers because technology is only a means to reach the end. And that is why it is very decisive for us to see to it that we do not focus on our target only and exclusively, so we don't want to use diverging semantics for different use cases. For Cloud A, for Cloud B, a different semantic. For C, a different semantic, a different HMI, another semantic. Or for the SCADA system, we want to have a different semantic. But the single source of proof of the information can be found in the sensors, in the control units, in the machines at the shop floor. And I'm talking about production-specific information. I'm not talking about engineering-related information, but I think that speaks for itself. At the source, and that is why in mechanical engineering we define the information variables coming from the control units and being made available to the control units. And we do that in a standardized way, only once with the technology OPC-UA. And to us, it doesn't really matter where the data will be processed. The only thing that matters to us is that we do not just want to standardize any data, but we look at the use cases that this data is going to be used for. The simplest use case that we all know is condition monitoring. Now, our experts coming from all the members and all the users sit together and they think about the variables which are necessary for the typical use case of condition monitoring of a CNC machine. They gather this information and then they move around in circles because they all understand it in a different manner. And it takes a long time, and everybody complains that it takes so long. But at the end of the day, somebody comes along and tells us, well, this is what is missing, and we need a stream because CS45A, and this is why the interchange doesn't work. So that is exactly where we have the point. Here, based on the use case, open for different use cases, data will be standardized. OPC-UA companion specification is going to become the global production language. And I spoke about domains. This is the first level. The OPC-UA is followed by the companion specs. We can shift data back and forth. That's not a problem. From A to B, everything that Hopper said also applies to our global production language. And for the companion specifications, it's only half as efficient because if you shift data from one place to another that nobody understands, and if you all have to think about where does this data come from which manufacturer, with which semantic, nobody will get out of that. So we need companion specifications. If you look at this in detail, you will realize that we're not talking about a movement where three different sectors have come together, but we are talking about a movement where big parts of machinery and equipment engineering have come together, committed themselves to one technology, and agreed on one single standardized semantic. You might say it again and again. The VDMA, the machine tools, were one of the first in connection with robotics, with plastic and rubber machinery manufacturers. And since then, many others have joined. If you take it into account that all these speak the same language and have to speak the same language, just like we as human beings, we can say hello to each other, then it doesn't matter whether you're a biologist, a mechanical engineer, a medical doctor. Hello is a word that everybody understands. Same holds true for machine language at the same level. For that matter, in addition to the specifications, which are domain-specific, we have developed the OPC-UA for the machinery, the highest level of interoperability, that is. Together with the companion specs, these systems can be used, which are domain-specific, but it can also be used standalone, separately, independently. If there are machines which do not fit into any of the categories or for which no specifications have yet been developed, contact us. But you can also use the OPC-UA machinery because the OPC-UA for machining makes it possible for you already today to come to terms with identification status, process values, job management, and energy management. All these different pieces of information have been standardized between all the different manufacturers and being made available. And to go with the OPC-UA domain specifications, they can be specified in such a way that the machine-specific information can also end up in this interface. What does this really look like? Well, it is practically the OPC-UA for machinery lays the foundation for all the other specifications. It can also be used independently. But then we have the companion specifications for a laser. And the laser is based on the machinery with the identification and the status. It will be complemented by machine tools, because a laser contains a lot of information which can be found in a CNC machine, but the laser machine has some additional information, and therefore you will find additional information in the companion specification for a laser. If you buy a laser with an OPC-UA specification or many, then you will find the basic information which is comparable with all the other machines. So the robot will give you the same identification compared to the laser or the CNC machine, plus specific additional information that all the other machine tools have at your shop floor. And you will find the laser-specific information on the tool that all the lasers are equipped with that you're using. But the machine tools, of course, will not be equipped with them. This is how the whole system is set up. A year ago, we asked ourselves the question, are we in the right buffer? Are we ready for the right challenge? So we conducted a study which revealed very clearly that at the current moment in time, 70% of the feed was given to that. We got 600 returnees, which said we have got OPC-UA under development or it's part of our development cycles. So OPC-UAs have already been implemented to a broad scale, and the companion specifications constitute the next important logical step. Why is what I just explained to you a minute ago. We have seen that this connectivity with one interoperable standard helped to develop the market even further, that the semantics are included. And if you're a manufacturer, customer, or integrator, or software developer, our recommendation is familiarize yourselves with that. Get to know the communication standards. Familiarize yourself with OPC-UA, no matter whether you develop software or whatever, the machine combines you all. Take the first steps, because the market is developing into that array. It will form part of the specifications lists. Now, if I try to summarize all of this, our approach is the following. We do not only and exclusively want to focus on connectivity, but nevertheless connectivity is of the essence. If you walk through the halls today, you see that there are many booths dealing with the digital twins or data sets. And if you focus on the digital twin, we deliver standardized data from the shop floor for all the information that you use for the digital twin coming from the shop floor. You can do this quite effectively and efficiently. It is most likely that machine has an OPC-UA or client-server connection already, so we just have to implement the semantics, and then it will be possible for me to use the digital twin and set it up in a very scalable manner. I'm not talking about simple MKS systems. I'm talking about general data that needs to be forwarded to the digital twin. And here the digital twins do not really differ all that much from each other any longer, with the exception of the MKS. And in the field of data spaces, the whole thing explodes even more. When we look at the data spaces where along the entire value chain, data has to be collected and be processed centrally in one single architecture, then it is even more important in this context to see to it that in the different sections along the value chain, from the different machines at the shop floor, we will retrieve comparable information. And this is why we currently cooperate, amongst others, with the Manufacturing X initiative in order to see to it that OPC-UA and the companion specifications will also be made available in the data spaces via the EPC. Alexander Proos, a colleague of mine, will prepare you for the next presentation. I will briefly tell you about what this is going to be all about, because what we are doing is that we say OPC-UA and the companion specifications lay the logical foundation, but in addition to that, we want to give a stimulus to the market. The first steps need to be simplified in order to use the system. Now, every single company cannot do that out of its own strength. Implementing OPC-UA, as Mr. Hoppe said, is no rocket science, but we have the initiative that is responsible for that just to cross this booth, where manufacturers, customers, clients, software manufacturers are brought together in a partnership. And this is where we make it possible for each of the parties to learn from each other. We don't want to redefine or develop new standards or use OPC UA or to rather change it, but we want to make people able to understand these technologies, test them out on a demonstrator over there at the booth. You will get some more background information, and this is the overarching goal that we pursue with Umati. And as I already mentioned, we try to bring users and producers together in one community where they exchange information and promise each other that they will ensure smooth implementation, and therefore OPCU is not only going to be a technical foundation for the sector, but it's going to be the language that we all speak, especially together with the companion specifications of OPCUA. We have a lot of partners by our side. The list is endless. You can find even more information over there at the booth. But you know, a lot is happening in the market, and that is the most important message I'd like to convey to you. A lot is happening in the market. There is the OPCUA in the market, the companion standardization, and you can get started if you have not yet done so. Gather your first experience, either alone or with the Umati colleagues, with the VDMA, with the UPC Foundation, and many other partners. Don't wait and sit back, relax, and then try to keep up, but get the necessary information that you know, acquire the necessary know-how that you need, and join in. Now, let me just briefly inform you about our own events, because they are very important also for non-VDMA members. First of all, one topic is going to be for interoperability. On the 28th of September at the VDMA, this event will be held. The WDMA, nonetheless, or Trumpf, will use this occasion in order to show you how you can use UPC UA specifications already today. And those who claim that there's so many interoperability solutions, UPC UA, E-Class, Pro Step, coming from different stages of the life cycle. And if you want to understand how things match, which one belongs there, this is your event. Apart from the OPC Foundation, E-Class will be there, IPTA, STEP, Automation Pro Step, many of us will meet in order to use this one single event to explain what the pros and cons of the different areas are, how do they differentiate each other, and how can they be complemented for each other. The registration list is open. Please register now, sign on, and go there in order to get some more additional background information. Okay. Now that's it for my part, and if there are any questions, I'm more than happy to